Okay, what's up, everybody? Happy, whatever today is. We are going to begin the Unit 4 assignments, and we begin with various roots and simplifying various roots. Now, you may know common roots, and I provide this sheet for you. And so you may know some square roots and things like that. Like, I can look at this file over here, and I can see, oh, the square root of 25. Okay, the square root of 25 is 5, and things like that. And you may know some common things as you go along. However, the roots, whatever we're doing, a lot of times won't come out to be happy-go-lucky numbers, and there will be some things left over and things like that. And so I'm going to teach you a couple methods that we can use to help simplify these roots. Okay, we can help simplify these roots, and I'll show you how to use this paper that I have off to the left to kind of help us with this endeavor. Okay, taking a look at number 1 of our assignment, we can see that we have a number, we have an X, and we have a Y. We'll get to the letters here in just a moment. And so what I noticed that this is a square root, and so the number is 100. And what I want to do is I want to break this down into what are known as prime factors. So there are various prime numbers, like 2, 3, 5, 7, 11, 13, etc., etc., etc. I have them listed on this page on to the left. Prime numbers. And what a prime number is a number that can't be divided by anything smaller than the number 1 or itself. Okay, so it is what it is. Like, I can't divide the number like 7 with anything smaller than it and get it to be equal to a whole number. All right, so I digress. What I want to do is I want to attempt to break this 100 down into prime numbers. And what I'm trying to do is I'm trying to divide. And you can use your calculator to help you out. And so what I'm going to do is I'm going to divide by the number 2 as many times as possible. And then I'm going to divide by the number 3 as many times as possible. And then I'm going to divide by the number 5 as many times as possible, until this number whittles down to be a prime number itself. Okay, it becomes a prime number itself. So here is my method of breaking down a root into its prime numbers. So I can divide 100 by the number 2, and that turns it into the number 50. So I kind of write this 2 alongside. So I can take 100 divided by 2. 50. I can divide that by 2, and I can get the number 25. Now, I cannot divide the number 25 by 2, so I'm done with the number 2. I move ahead to the number 3, and I see, can I divide the number 25 by the number 3? And no, it doesn't. When you divide 25 by the number 3, you get an answer of 8.333333. Okay? You get this 8.33. So no, you can't divide it by 3. So I move on to the next number. Divide it by 5. Yes, I can divide it by 5, and that yields 5. And that's where I stop. So this 100 turned into a prime number. And I make this L-looking shape, cutting off the very last number that I'm left with, and I make this L-looking shape. Okay. Because this is a square root, what I want to do is I want to make groups of 2. If it was a, okay, this is a, oops, sorry. This is a square root. So I make groups of 2. If it's a cube root, I make groups of 3 of the same number. And if you can make a group of it, awesome. If you can't, oh well, it is what it is. Okay, so I can make a group of this 2, and I can make a group of 5. Now, if you are able to make a group, flash forward to what the answer is going to look like. If you are able to make a group of it, cool. It comes to the outside of your answer. So the outside of this like unfilled in root is going to be the number 2. And I can also take out a 5. Notice nothing is unpaired. So there is no numbers that I leave on the outside. And then what do you do with multiple numbers, whether they be in or out, is you multiply them. So again, if you flash over to our list that I have to the left, I kind of helped us along with this process. For numbers 1 through 100, I broke it down. So I noticed that 100 is 2 times 2 times 5 times 5. And so what I can see is I can make a group of 2 and 5. So a 2 will come out, a 5 will come out, which is a 10, and then there's nothing paired. It'll make more sense when we do more problems, but this is what we have accomplished, and this is what we are doing, and this is how we begin. So let me write it just a little bit more neatly. So if you want to choose this method, which never proves you wrong, all right, so right now my answer is 10 on the out, nothing on the in. Because I brought a 2 out and a 5 out, and nothing is left over. Okay. What a square root is this. If I can multiply something by itself, okay, it comes out. For instance, if I had 2 times 2, which is the same thing as saying the square root of 4. The square root of 4 is equal to 2 because I take this answer and I multiply it by itself 2 times to get this answer. So if I have a multiple of itself, okay, that is what the result is. So 2 times 2 is 2. Okay. With this being said, take a look at how many x's I have in this problem. I have x to the 4th, which is same thing as saying x times x times x times x. Okay? So my question is, what is the square root of that? With the same process, I make groups of 2. So I can make 1 group of 2. I can make 2 groups of 2. Outside stuff multiplies, so what this results in is x times x is x squared. So I'll have x squared on the outside. Now, how can I simplify that process? Long story short, what you can do with exponents is this is a square root, which means there's like a little invisible 2. So what you can do is you can divide exponents, not numbers, but you can divide by 2. So 4 divided by 2 is 2. Okay, 4 divided by 2 is 2. And so I'm able to take out 2. Now on this y portion of the problem, this y is 25. So 25 divided by 2 is 12.5, or 12 remainder 1. If you recall back in the day when you may have learned how to divide, you get these remainders. So 12 remainder 1. What a 12 remainder 1 implies is I'm able to take out 12, but I have 1 left over. So 1 y has to stay, and this is kind of like where you leave leftovers. Okay, so I'm able to take out a 10, 2 x's, 12 y's, and I have a leftover of 1 y. And so this is your process simplified. Okay, let's take a look at number 2, and let's kind of get a method worked out. All right, so 12. Looking at my side paper, 12 is the same thing as saying 2 times 2 times 3. All right? And then I have x squared also in this problem. All right, so what does that mean? All right, so the 12, I have 2 times 2 times 3. So the 12 means I have a 2 on the out and a leftover 3. Leftovers stay on the inside. So I have a 2 paired up, and then I have a 3 left over. Okay, so that's the 12 portion of the problem. The x squared. I divide, in this case, by 2, and that's 1. Comes out to be a perfect 1. So what does that mean as far as the answer? Is I'm able to take out the number 2, 1x, and I have a leftover of a 3. All right, here we have the 5th root. So technically, I'll show you the long way, and then I'll kind of hint you in on some of the tricks. So the long way of doing this, 1024. I don't think my table goes up quite that far, but I see that this is an even number, so I can take out an even number. I see that that's an even number, so I can take out a even number on that. So it's 1, 5, 6. That's an even number. I can take out a 2, so that's 1, 2, 8. I can take out a 2, which is 6 and 4. I can take out a 2, which is 3 and 2. I can take out a 2, which is 1 and 6. I can take out a 2, which is 8. I can take out a 2, which is 4. I can take out a 2, which is 2. Woo! Now, do I expect you to do all that? Heck, no. But anyways, I'm just showing you and proving a point. Notice how this is a 5th root. Notice how this is a 5th root. So what I'm looking for is groups of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So of the 1024, I'm able to take out a 2 and a 2, which is AKA 4. If you look at the reference page that I gave you, I do take things up to x to the 5th. So if I look for the number 1024, I can see that the 5th root is indeed 4. So sometimes when you get to these upper roots, you can use this table to kind of help you out. And so this is a 5th root, and so that comes out to be 4. So if you just straight up know the root, that's fine. You can kind of cheat the system and say, oh, I know that answer is 4. That's cool. I just straight up know that answer. However, if you need to break it down, you have the ability to break it down. Okay. Again, the outside is 5. So here I'm not dividing by 2, but I'm dividing by 5. So 5 divided by 5 is 1. The y, I divide by 5. And the best I can do is 4. 4 takes me up to the number 20. So that means that there's 2 left over. So what's my answer? Of the number, I'm able to take out the number 4. Of the x's, I'm able to take out 1x. Of the y's, I'm able to take out 4 of them, but there is 2 left over. Okay, again, this next problem is to the 5th root. I know it's kind of hard to see, but this is to the 5th root. So I'm just going to see if I can maybe cheat the system and see if there's the 5th root of 243. There is. Oh my gosh, cool. So the 5th root of 243 is 3. All right. And 20, exponents you divide. I divide by 5, and that comes out to be a perfect 4. So what's my answer? The number is at outside 3, The x's I'm able to take out 4 with nothing left over. So since there is nothing left over, I don't put anything on the inside of the root. This is, again, exclusively for leftovers. So nothing is left in, so I just kind of ignore that, and that's your answer. All right, this is a third root. I don't know if you can quite see it. Let's just see if we get lucky with a third root looking for the number 27. And what do you know? We are lucky. It is the number 3. So 27 is the number 3. 6 divided by 3 is a perfect 2. So of this answer, the number is 3, the x is 2, and there is nothing left over to put on the inside, so I don't write anything on the inside. All right, number 6. Again, this is a third root. So I see if I get lucky, look for the number 24. The number 24 is not in the third root. So let's go back to those prime factors and take a look at this. So 24, I notice is 24 is 2, 2, 2, 3. Twenty-4 is 2, 2, 2, 3. Because this is a third root, I'm looking for groups of 3. So I'm able to make a group of 3 of those 2's. So that's a 2 on the out and a leftover 3 on the in. So long story short, what the 24 is 2 on the out, 3 on the in. That's what the 24 is. Okay, the x, there's 9. 9 divided by 3 is a perfect 3. The y, 5 divided by 3 is 1, remainder 2. 1, remainder 2. So, what's the answer? So of the number, I was able to take out a 2, but there was a 3 left over. Of the x's, I was able to take out 3 x's. Of the y's, I'm only allowed to take out 1 y, and there is 2 left over. Okay, that is the simplification of roots. That is the simplification of roots. Again, you may want to use this page if you can get lucky and identify a straight up root. That's awesome. If not, we have the ability to break down whatever it happens to be. If you have a number that is bigger than 100 and you need to do this process, like for instance, if they say, what is the square root of 120? Okay. Chances are what you can do is you can kind of start the process the way that I showed you earlier. Like I see that 120 is an even number, so I'm able to take out a 2. And through simple mathematics, it turns into the number 60. All right, so if you have a number that is larger than 100 and you still want to use this page, that's fine, because it'll just take a couple problems. You might have to divide once or twice. And then what will happen is it will become a number that is less than 100, and then you can use this page. So I see that 60 is 2 times 2 times 3 times 5. All right, so all you have to do is understand that, okay, if 60 is 2 times 2 times 3 times 5, all I do is I slap on another 2 to that list. So if this is a square root, I can make a group of 2's. Okay, so that would mean a 2 on the out, and the leftover would be a 2, a 3, and a 5. which is 30. I'll do one more example like that so you can kind of see what I'm talking about. Let's go ahead and take the square root of, actually let's take the third root of, let's take something large. Oh, let's go with, take the third root of 328. So again, that's over the number 100, so my list to the left doesn't really help out. So 328. So it's an even number. I can take out a 2. Okay, still over, so 2. Okay, so it turns into the number 82. 82 is the same thing as saying 2 times 41. That's the best that can get. So what is this actual list? It's 2 times 2, okay, of the first 2s that I took out, times 2 times 41. So because this is a third root, groups of 3, so that's a 2 on the out, 41 is left over of a third root. All right. On to the next question that is being asked here, and that is asking about addition and subtraction of roots. Okay. To add and subtract roots, what the roots have to be is they have to be the exact same. So if we're talking about square root, or excuse me, cube root 3, I can only add and subtract that to other cube roots of 2, I can only add and subtract that to the cube roots of 2, and then this doesn't change. Okay, so what am I talking about? Let me be a little bit more clear. Let's say I have let's say I have 3 cube root 2, and I want to add 4 cube root 2. All right, so as I said, the inside, the roots have to be the same to allow you to add or subtract. So because the roots are the same, I add that outside number. So 3 plus 4 is 7. But the inside does not change. It stays whatever it is. So 3 cube root 2 plus 4 cube root 2 is 7 cube root 2. Okay, so the insides have to be the same. Remember that if there isn't a number written out front, there's an invisible 1 out front. There's an invisible 1. So here the roots are the same. So 3 cube root 2 plus cube root 2 is aka 3 plus 1. So that'd be 4 cube root 2. Again, you only add and subtract. The root has to be the same, and then you only add and subtract the things that are on the outside. Now, if the root is not the same, okay, if the root is not the same, this root portion, then you cannot add and subtract that together. So if this were the problem, that's as good as it gets. Because the roots are not the same. You cannot add and subtract those things together. They are different. You cannot add and subtract them together. Okay. So how the heck do I do the problems like I have written here in number 7. So I notice that right now, the roots are not the same. I have a third root of 2, and I have a third root of 16. They are not the same. I cannot add those together. How the heck am I supposed to do this problem? Well, when you are presented with these problems, what we do is we try to, what you want to do first is simplify them. Right, so the first one is the number 2, and 2 is just straight up the number 2, so that it isn't paired with anything, so that's just going to be 2, cube root 2. 16 is the same thing as saying 2 times 2 times 2 times 2. All right, so I can make a group of 3. So that means 2 comes out with that grouping, but then I have 1, 2 left over. And so the leftovers go on the inside. So upon simplification, I see that this is 1 cube root 2 minus 2 cube root 2. So on first investigation, it looked like I couldn't do this problem, but after simplifying the fraction, oh, I see that these roots are now the same. I'm able to do this problem. And so this is going to be 1 minus 2. So that'll be negative 1 cube root 2. How it'll probably look on, if you look for an answer, a lot of times they don't write 1s. It'll probably look like negative cube root 2. That's probably what the answer is actually going to look like, but I just wanted to be overly obvious on why that's the answer. Okay, so right here, right now, nothing looks good. Okay, I do know that the square root of 36 is straight up the number 6 with nothing left over. Okay, and oh, you can't add like a number with a root of something. Again, the roots have to be the same. So this square root 2 only can operate with other square root 2s. So again, if you have something like this, that's as good as it gets. Okay, the number 12. Okay, here we have 4 root 12. So the number 12 is 2 times 2 times 3. Okay, because this is a square root, that means a 2 goes on the out and a 3 is left over. Notice that there's already an outside 4. So again, if there's multiple numbers on a side, you multiply. So this 4 root 12 is actually 8 root 3. Again, 2, you can't really do anything with 2. So this is going to be negative 9 root 2. All right, take a look here. Look for similar roots. Nothing has a similar root. So that is what it is. It's 6 plus 8 root 3 minus 9 root 2. I'm unable to add or subtract any of those. And so that's as good as it gets. Okay, multiplication. When I multiply, I'm going to write a side example. Let's say I have 2 root 3 times 4 root 5. 2 root 3 times 4 root 5. All right, when I multiply roots, numbers multiply numbers, roots multiply roots. Numbers multiply numbers, roots multiply roots. So 2 times 4 is 8, 3 times 5 is 15. Once you get done, just be on the lookout on if you can simplify the root that is left over. here, 3 and 5, nothing matches up. So it is what it is. Okay, so numbers multiply numbers, roots multiply roots. So here I have a big parentheses. So what we have to do is we have to multiply into that big parentheses. So that's 1 root 3, and then I multiply. So 1 times 2 is 2, root 3 and 5 is 15. The next one, 1 times 1 is 1, 3 and 7 is 21. Okay, 15 is 3 and 5, nothing pairs up. 21 is 3 and 7, nothing pairs up. So these roots don't simplify to be anything else. So this is just going to be 2 root 15 plus root 21. That's as good as it gets. Okay, I think we talked about how to do this in the previous chapter. However, I just had a student ask me the other day, and they were kind of baffled on how to multiply a binomial, okay, a two-numbered number. So let's say I have 2x minus 3 times 3x plus 5 or something like that. Okay, again, how you multiply something like this is you take this first term and you multiply everything of that next term. So 2 times 3 is 6, x times x is x squared. 2 times 5 is 10, x times nothing is x. All right, so you do that until you completely multiply that second parentheses. Cool. And then you bump over the number in question and you repeat the process. So negative 3 times positive 3 is negative 9. Nothing times x is x. Negative 3 times positive 5 is negative 15. And then what I can do in this particular problem is I'm able to add and subtract the singular x's. Thus, this would be 6x squared plus 1x minus 15. Okay, now, with that being said, that process being said, the same holds true with our problem here. So we have 1 root 2 minus 5 root 6. We have 7 and minus 2 root 3. So what we do is we begin with that first term and we multiply everything of that next parentheses. So numbers multiply numbers, roots multiply roots. So 1 times 7 is 7, and then root 2. Okay, the next one, the 1 root 2 and the 2 root 3. So 1 times negative 2 is negative 2. 2 and 3 is 6. Okay, so I multiplied everything of that second parentheses. I bump over, and now we're looking at negative 5 root 6. And we repeat that process. So negative 5 and 7 is negative 35. And then root 6 with nothing is root 6. Negative 5 and negative 2 is positive 10. 6 and 3 is 18. Okay, so on quick investigation, I can put these numbers together. So that's negative 37 square root 6. Okay, I also have a 7 root 2, and I also have a 10 root 18. Okay, now before I skip gleefully away that this is the right answer, let me just check these roots to see if they can simplify anymore. So 2 is just straight up the number 2. It is what it is. 6 is 2 and 3, so nothing pairs up. 18 is 2 times 3 times 3. That 3 can pair up. So what happens is that 3 can pair up, which means it comes to the outside, leaving the 2 all by itself. So this is technically 2, and a 3 comes out, which would make that 30 on that outside. Because the 10 is already out there, it is joined forces by a 3, and so that would be in essence 3 times 10, which is 30. So now take a look at our answer and see if there's anything else that can be done. What I notice now is I have some square root 2's. I'm able to add and subtract those things together. So they would add to be 37 square root 2. And then there's that 37 square root 6 just there. Okay, so again, if I had to boil the main idea, like what's like the 1 or 2 things that you should probably take away from this this piece of information is, okay, if you have a number, okay, you can use this list and see what the factors of them are. So this is 2 times 2 times 2 times 2 times 5. Okay. Use that outside root as the indicator of how many, what size groupings you have to make. Here, I need to make groups of 3. Okay, I can do that. If you are able to make that type of grouping, that goes on the outside. So that grouping of 2 means that there's a 2 on the outside. However, take a look at the things that you didn't have enough of to make groups. I have a leftover 2 and a leftover 5. Multiple things on multiple sides multiply. So the outside is 2 and the inside is 10. So that is basically how you simplify a number. It's basically how you simplify a number, straight up. Okay, letters. Say I have the 3rd root of x to the 6th, y to the 7th, z to the 8th, and then let's go w to the 9th. When it's an exponent, what you do is you try to divide the exponent. Try to divide. So 6 divided by 3. Okay, that comes to a perfect 2. 7 divided by 3 is 2, remainder 1. 8 divided by 3 is 2, remainder 2. 9 divided by 3 is a perfect 3. So, what is the answer? So, of the x's, I'm allowed to take out 2 of them. The y's, I'm able to take out 2 of them, but there is 1 left over. So there's like an exponent 1 on that inside y. It doesn't show up because you don't write exponents of 1, but you get the idea. The z's, I'm able to take out 2 of them, but here there are 2 left over. And the w, I'm able to take out 3 of them. So I take out 3 straight up w's, and there is none left over. So this would be your simplification right there. So that's the next key item of today. Addition and subtraction. I'm only allowed to add and subtract things that are exactly the same. All right, so if I have like the 4th root of 3, it's only able to add and subtract other 4th roots of 3. Okay, it's only able to add and subtract other 4th roots of 3. If I have, like 2 and 1, okay, because they're both fourth roots of 3, I'm able to add that. So that's 2 plus 1. So that would be 3, fourth root of 3. The inside doesn't change. You'll only add and subtract that outside number. Now, a lot of times, as we saw, they don't just blatantly tell you, this is a fourth root of 3. All right? So you might see you have like the fourth root of 249. Let's put a number on that. Say I have the number 249. Or actually, no. Let's make that a little bit more easy. Sorry. 162. Okay. Sometimes they'll camouflage what they're doing. That's still a bad example. I'm sorry. Yeah, sorry. Nailed it. And so what your original problem might look like is something like I have written in red. And so on first investigation, oh, no, I can't do that problem. I can't do that. The roots are not the same. I can't do that problem. All right, but if I take a look at it just a little bit more closely, I see that the number 48 is 2 times 2 times 2 times 2 times 3. Okay, the number 48 is 2 times 2 times 2 times 2 times 3. So if I'm making a fourth root, what I'm able to do is I'm able to take out a 2 with a 3 left over. And then so something that originally looks like it's impossible now becomes possible. So they're not going to, just make the problem blatantly obvious for you. They're going to make it just a little bit more difficult. So if you do see these additions and subtractions, simplify and then see if you can add and subtract. And last but not least, the thing that you need to be able to take away from today is that in multiplication, roots multiply roots, numbers multiply numbers. So if I have 2 third root 6 times 5 third root 7, 7. Okay, numbers multiply numbers. 2 times 5. Roots multiply roots. 6 times 7. Huzzah. Just take a quick glance to see if your answer can simplify. No, I can't make a third root of anything out of that. So thus, that is your answer. So this is the main topic of today's lesson right here.